In this lesson, we're going to start using our calculators, our graphing calculators, to solve systems of equations using matrices. But first, we're going to cover a few definitions. A matrix is in what's called row echelon form if it satisfies the following conditions. The first non-zero number in each row, reading left to right, that first non-zero number is going to be a 1, and that's called the leading entry. It's usually the first value in the row, but sometimes there are zeros in front of it. The leading entry in each row after the first one is to the right of the leading entry in the row immediately above it. And then all rows consisting entirely of zeros are at the bottom. So that's what we call row echelon form. So zeros, they're at the bottom of the matrix. And then we have something called reduced row echelon form. If it has all of these conditions plus this extra one, every number above and below each leading entry is 0. If we can put a matrix in reduced row echelon form, it's really easy to solve the system. It's practically solved for you. Because think about it. If we have all zeros, with the exception of one value in our row, then with the coefficient of 1, basically the final column is going to be the solutions to the system of equations. I'll show you that in an example coming up. But first of all, let's just look at these three examples of row echelon and non-row echelon form. The first one is considered reduced row echelon form because every leading entry, there's a 1, if I come down here, this is a 1, this is a 1. Every leading entry is a 1, and every value above and below the 1 is 0. This row doesn't count because he's not a leading entry. This row has zeros and a 1, and this row has zeros and a 1. So that's called reduced row echelon form. The next one is row echelon form because for every leading entry I have zeros beneath it. And over here it's nothing because this one might be a leading entry, but the next one has a 1 up here, and it should be a 0. So this is not row echelon form. And you see here the row of zeros are at the bottom for both reduced row echelon form and row echelon form. So next we're going to talk about the calculator steps to solve a system of equations. Alright, in your graphing calculator you have a matrix button and a matrix menu. On most of the calculators nowadays, that button is a direct button on the front of your calculator. For older calculators, I think it's you have to hit the second value first, but you should see matrix on your calculator, and then when you go in, you will select edit to edit the matrices. Now we're going to do this in class where I can put it up on the screen, but I just want you to write down these steps now so you can refer back to them. And when you edit a matrix, you have to dimension it first. So you have to tell the calculator how big the matrix is going to be. And as I said before, when we dimension a matrix, it's always rows first and then columns. The number of rows and then the number of columns. So let me give you a system that you can practice putting in if you happen to have your graphing calculator with you. If not, we're going to do this in class as well. So here's a system. 4x plus 8y minus 4z is 4. 3x plus 6y plus 5z is negative 13. And negative 2x plus y plus 12z is negative 17. If I were to write out the augmented matrix for that, you would just put in the coefficients. And this is what I'm going to put in the calculator. So you write it out by hand first, and then we're going to dimension it. This has 3 rows and 4 columns. So the dimension you put in your calculator is 3 by 4. Again, we're going to do this again in class, so if you don't have a calculator with you, that's okay. And then once you put that in, you're going to go back and in the same screen, you're going to put in every value. It fills in by row, so 4 enter, 8 enter, negative 4 enter, 4 enter, and then you keep going until the entire thing is in. Once you do that, you need to quit out of the matrix. So that's second quit. and go back in again. So you go back into the matrix menu. This time you want to select Math. And in Math, in the Math menu, there is a command that's reduced row echelon form. That's what you're going to call up to the main screen. Then go back into Matrix, and this time in the first menu you're going to select the matrix A where you entered all that data in. Once you have all that, you're going to press enter, and it's going to give you a solution to this matrix. We will talk about that solution when we do all this together in class, but these are the buttons that you need to remember for your calculator. Matrix, the edit menu to enter your matrix into it after you dimension. Then you get out of there, you go back into Matrix, you select Math, you choose Reduced Row Echelon Form, and that goes to the main screen. You choose Matrix again, you choose Matrix A, and then you hit enter. So that's what we're going to work together in class on. So it's going to be much more worthwhile for me to show you how to solve this using reduced row echelon form in class with calculators. So we're going to skip over this section, and I'm going to finish up today by defining inconsistent and dependent systems. So once you have a matrix in reduced row echelon form, you can look at it and the values will tell you whether you're going to have a solution or not. So if you solve a system and you end up with one solution, that means each variable is going to be a leading entry. Each variable is going to have a coefficient of 1, and you're going to have a final value. Each variable is going to exist. And so this is a consistent system. This is the standard kind that we see. It's consistent because I can say that z is equal to 8. That makes sense. And y plus 2z is equal to negative 2, and x plus 6y minus z is equal to 3. That all works. That's row echelon form. It might not be reduced row echelon form, but row echelon form will show you that. Now, if a system has no solution, you'll get this goofy thing at the bottom. All the zeros with a value at the end. What that's saying is 0 is equal to 1. And that's never true, so we call that inconsistent. It doesn't make sense. 0 is not equal to 1. It's inconsistent. Finally, if you get a row that's all zeros, that has an infinite number of solutions because the zeros are created because one of these equations ends up being a multiple of the other. So I really only have two equations, two independent equations here. This is a dependent system. So that system will have an infinite number of solutions because one variable will work, or two of the equations are very similar. So again, we're going to leave the rest for class so we can use our calculators to solve systems and also determine if they are consistent, inconsistent, or dependent.